In an astronomical telescope, is normal adjustment, a straight black line of length L is drawn on inside part of the objective lens. The eyepiece forms a real image of this line. The length of this image is L. The magnification of the telescope is what we need to find here. Okay, let me draw the simple diagram here related to this particular statements. Okay, on the same coaxial here, two lenses are there, that is telescope. One is the objective lens. This is assume this is the objective lens, and here is the eyepiece lens is there. This is the eyepiece lens, and inside this objective lens, one black line is drawn with the length of L, and this eyepiece forms a real image of this line. That is somewhere here the real image will fall. This is I, or this is small l. Then here the magnification of this telescope, there is a f0 plus fe here. Okay. Then this is the objective lens, and this is the eyepiece. Okay. The magnification of the telescope is what we need to find here. Okay. We know that in normal adjustment, the final image is formed at infinity. Then the angular magnification is given by, that is m is equal to f0 by fe. This is the angular magnification. Here, for the image formation of the straight black line by the eyepiece, that is u is equal to minus f0 plus fe. So, by using the lens formula, that is 1 by v is minus 1 by u is equal to 1 by f. Then 1 by v is minus 1 upon minus u is equal to f0 plus fe is equal to 1 by fe. Then v is equal to fe into f0 plus fe divided by f0. Then further we can simplify this one as, that is hi by h0 is equal to v by u, that is nothing but minus L by capital L is equal to fe by fe into f0 plus fe whole divided by f0, this whole divided by minus of f0 plus fe. Then we get the answer f0 by fe is equal to L divided by small l. Then we can write this is the magnification of the telescope. Then m is equal to L divided by small l. This is in the option A we can see this answer. So option A is the right answer.